Welcome to another mathematics presentation. So in this presentation, we are continuing answering questions that are based on travel graphs. So here is our question. The question reads, the diagram below shows the speed time graph of a particle. The particle started from rest and accelerated uniformly for 10 seconds. It then traveled at a constant speed of 20 seconds and then accelerated to rest. So this is the diagram that is showing the speed time graph of the particle. So we have our first question right here. Find the speed v the particle reached if its acceleration was 2 meters per second square in the first 10 seconds. So when you look at this graph, you'll be able to see that the particle started accelerating from here up to here in v meters per second in 10 seconds. So here we need to find the value of v. So to find the value of v, we are going to assume that we are finding the acceleration. So we are going to write acceleration is equal to final velocity minus initial velocity over time. Now here we need to know the value of the final velocity, initial velocity, and time. So in the question they have given us the acceleration, they have said the acceleration was 2 meters per second. So meaning that the value of a would be equal to 2, okay, because that is the acceleration you have been given. Then v, which is the final velocity, which is this one right here where we have a v, okay, so v will be equal to v, will replace the v. Then u, this is the initial velocity, will be equal to 0. Then time, they are saying in the first 10 seconds right here, in the first 10 seconds, so time will be 10. So I'm going now to write where there is v, final velocity, will put v the way it is, v minus initial velocity is 0 over the time is 10 equal to, what is the acceleration? It's a 2. So from this stage we are going to have v over 10 equal to 2. So v minus 0 is v over 10 equal to 2. So we divide by 1, then we cross multiply, v times 1, it's v. So this tells us that v equal to, so 10 times 2, this will give us 20 meters per second. So you know that here there was 20 meters per second because we have found the value of v to be 20 meters per second. So we have answered our question 1. Let us now move on to question B. Question B reads, given that the total distance covered was 750 meters, so the total distance for this entire journey was 750 meters. Find the value of t in the diagram. So we can see that here in time we have 0, 10, 30 seconds, t seconds. So we don't know the final time which was here. So in order for us to find the value of t, we have been given that the total distance of this entire journey was 750. So how can we find t? We are going to assume that we are finding the distance of this shape, because when you look at this shape, this is a trapezium, okay? So if you have a trapezium, you need to come up with a formula for finding the area under the trapezium. And this formula, we are going to write, we'll say distance equal to a plus b, then here we put height over 2. So a is presenting from here up to here, okay? This is where the a is. So from here to here, we have time intervals. Here we have a 10, here we have a 30. So we need to find the difference between 30 and 10. That will be the value of a. So this shows that the value of a is a 20, because 30 minus 10 is a 20. Then for b, is from here up to here, okay? So here you have a t, that is the time which is here. Here we have a 0. So t minus 0 get a 0. So b is equal to t, okay? Then the height is from here up to here. This is where the height is going to be. And this height, its value is correspondence to this 20. So the value of the h is equal to 20. So having identified that, we can now just substitute, okay? So we are going to substitute where we have d. So we know that d is our total distance. So here they have given us that the total distance is 750. So we are going to write where there is A right here. Where there is A, we are going to put a 20 plus where there is a B, we are going to put a T over 2, okay, times where there is H, we'll put a 20. Then we equate this to the total distance. In this case, the total distance is 750. So I do hope that you are following. Now, upon coming up with this, okay, upon coming up with this, what are we going to do? So we can do here 2 into 20 is a 10. So we have 20 plus T times 10 is equal to 750. So we can still divide this by this T, even here divide by this T, because this is paper 1. So ensure that you know how to work out these calculations. So 0 and 0 out. So what are we remaining with? We are remaining with 20 plus T equal to 75. Okay, so this is that we are remaining with. So 20 plus T is equal to 75. Here I've cancelled this 0 and this 0. Now from here, this T, sorry, we correct the right terms, meaning that this 20 will go where 75 is, because the 20 and the 75, these are the like terms. So we are going to write 20. So T equal to, so 5 minus 0, it's a 5. 7 minus 2, it's a 5. So T is equal to 55 seconds. So meaning that right here where there was a T, okay, meaning that right here where there was a T, it was 55 seconds. Okay, so we have answered our question. Now let us now answer our last question, which is our question C right here. What distance was covered in the first 30 seconds? What distance was covered in the first 30 seconds? So they want us to find the distance covered in the first 30 seconds. So the first 30 seconds is from 0 up to 30. So we are considering this area. This is the distance that we are considering, just ending up to 30. So when you look at the shape, this is the shape that you are having. It is also a trapezium. So we are going to use the same formula where we say distance equal to A plus B, then H over a 2. So we are going to say distance equal to, so still A is this one, but for B it's not from here up to here, no, because we have said distance in the first 30 seconds. So it's from here up to 30. So this is the B. So the B now, it will be B equal to what? 30. Because 0 and 30. 30 minus 0, it's a 30. Now for A, it's between this time interval and this one. So 30 minus 10, the A will remain a 20. For height, is the same from here to here, which will be the same, which is a 20. So I'm going to substitute now those values. Where there is A, we'll put a 20 plus. Where there is B, we are going to put a 30 over 2. Then here, times where there is height, we put a 20. Okay, from here, we're going to write distance equal to. So this and this gives us 50. Okay, times 2 here 1, 2 into 20, it's a 10. So times what? A 10. Okay, so therefore, distance equal to 50 times 10. This gives us 500 meters as our distance in the first 30 seconds. So we have now come to the end of our session. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye-bye.